Welcome to the final video lesson on using the factor label method to convert units. In this lesson we'll be looking at three new examples that look at things that can be slightly more challenging. As you make your way through, if you feel confident, please pause the video once you have the problem in front of you and the relationships that you need, and give it a try. Then you can watch the video to follow through and see if you follow the appropriate process. So let's take a look at our first example. Our first example here is a distance example, and we're looking to convert 67.42 parsecs into light years. So to do that, we need to kind of know how many parsecs there are in a light year or how many light years there are in a parsec. So we can look that up online, but here you'll have it. And since this isn't on your equation sheet that you'll be provided for any assessment, this would be one that it would be given to you in the problem or as it's given to you right here. So once I know that relationship, this should be a fairly straightforward unit conversion because we know what we're given. We're given 67.42 parsecs and we know where we want to be as far as the number of light years is concerned. So we start out by writing 67.42 parsecs, and then using our relationships that is there on the right hand side, we want to get rid of parsecs, so parsecs is going to go in the denominator of our fraction, and 3.26 light years is going to go in the top. So that means my parsecs cancel out, and I multiply across the top. 67.42 times 3.26 leaves me with 219.79 light years divided by 1, which is just 219.79 light years. So let's move on to example number 2 then. Example number 2 is the first time that you might be seeing completely arbitrary and made up units. In this question we're asking about converting from blues per duck into greens per goose. So we need to kind of know what our color relationship is as well as our bird relationship is. And these again can be defined for you. Now, you'll notice here that with these relationships there's something a little bit different than any of the other relationships that you've seen or that you've used, in the fact that it comes with neither side of the relationship being set equal to 1. Okay? The relationship works exactly the same way, with canceling out, putting the piece you want to cancel opposite of where it originally exists in our fraction. You could reduce to get 1 on either side, but that's just adding another layer of work to what you have to do. So you can use these relationships just exactly as they exist right here. So what do we know? We know that we are 14 blues per duck, and we want to figure out how many greens per goose that is. So we know that 14 blues per duck actually represents 14 blues divided by 1 duck. So if that's the case, then I need to first get rid of my blues, then I'll get rid of my ducks. So to get rid of blues, I'm going to take that exact relationship that I have. I'm going to put my 3 blues in the bottom and my 4 greens there in the top. Remember, it doesn't matter that it doesn't have a 1 there on either side of that fraction. So that allows me to cancel out the blues. So I have, now my color is greens. That's where I want to be. So the next step is to then move from ducks to geese. So I have 1 duck down in the denominator. So that means I'm going to put my 6 duck up top and my 2.5 goose down there in the bottom. Again, that'll cancel out ducks, and I'm left with greens over goose, so that means I'm exactly where I want to be. So all I have to do is multiply across the top, multiply across the bottom, and then divide the top by the bottom, which leaves me with 44.80 greens per goose. These can be complicated problems, but remember, the process is exactly the same. All you need to do is identify those relationships and exactly how you can use those relationships. Our third and final example here brings a new wrinkle in that we have a squared unit that we are discussing. Okay, in this question we're looking at a lawnmower that's able to cut 12 square meters each minute, and we want to know how many square centimeters the lawnmower cuts each second. So we're familiar with these units: meters, minutes, seconds, centimeters. So these aren't necessarily undefined relationships. It's just how we're going to attack them, because we know that there aren't 100 square centimeters in a square meter. There's more than that, because the 100 to 1 relationship only relies on the centimeters to meters relationship. So let's take a look here. I have 12 meters squared divided by each minute. But what does that meters squared actually represent? Well, we know from math class that meters squared is just m times m. And if it was meters cubed, it would be m times m times m. So what I want you to do when you find a problem, or you come to a problem that looks like this, is rewrite it like that. Rewrite it as 12m times m divided by 1 minute. The reason I ask you to do that is now visually we know how many m's we have to get rid of. So now I can use my relationship of 1 meter equal to 100 centimeters and get rid of my meters. But as you'll notice, I've only gotten rid of one of those meters. So what does that mean we have to do? We have to do that exact same step a second time. So I have both of my meters cancel out. My third step here, since I'm now in centimeters times centimeters, which is where I want to be, is to convert minutes into seconds. So that's an easy relationship for us to use. 1 minute equal to 60 seconds. Put the minute in the top part of my fraction because we want minutes to cancel out. And then I'm left with centimeters times centimeters over seconds. And that's exactly what we want to see, because we want centimeters squared per second. So now all we need to do is multiply across the top, multiply across the bottom. And as I multiply across the top, it gives me 120,000 centimeters times centimeters divided by 60 seconds. Reducing that leaves me with 2,000 centimeters squared per second. As is the case with all of our examples and all of our practice, if you need help or you get confused or you get lost, don't be afraid to rewatch the video, and certainly don't be afraid to ask the question during class.